Right, welcome back. And now we're continuing with our lesson, and specifically now we're going to talk about the equations of motion that we can use to solve for problems based on projectile motion. Now, like any other motion that we have worked on, we know about rectilinear motion, motion in a straight line, and at grade 10 we looked at equations of motion looking at distance or displacement along the horizontal. Okay, now the only difference now is that when we talk projectile motion, the displacement we're talking about, it's a vertical displacement, and because it's vertical displacement, we begin to change some of the notations in the equations, as you are going to see. Now you know basically the equations, and I will suggest that you make sure you know these equations. Don't wait for the data sheet to look at what the equations look like. You must be able to write them correctly without any problem on your own. Now let's start with the first one, the simplest one. Here V final equals V initial there plus A delta T. Okay, that's the simplest one. And if you remember well, this comes from the fact that when we defined acceleration, we said acceleration is change in V over change in T. Now, if we have that, you would see that if we make V here the subject of the formula, we would have it as delta V equals A times delta T. But delta V is V final minus V initial. So if you leave V final, which is this here, as the subject of the formula, you would have V initial taken to the other side here. And then it becomes plus V initial. So you have got V final equals V initial plus A delta T. But because we're specifically talking about projectile motion, motion in an up and down directions, okay, we know that for that situation, the acceleration that acts on the projectile is a specific acceleration due to gravity denoted as G, and we know its value. That's 9.8 meters per square second, the units there. So that is G. So what does that mean? It means that for every A that we see, we are going to see G coming into that. Like you see, V final equals V initial plus G delta T. G delta T. This Y here is just placed or put there to remind you that this is a projectile motion. It is along the vertical. You don't have to have it there. So you just have to have V final equals V initial plus G delta T. That's good enough. The next one, as you can see it, the next equation of motion, you can immediately tell what is going to happen here. We know that this should have been put as delta X there. But because we're going to talk about up and down motion, that in the vertical is shown or denoted by the letter Y. And therefore, this will be delta Y equals V initial delta T plus half G delta T squared. So here we should have it as delta Y. Okay, like I said, you don't have to show that because it is just reminding you that we're talking vertical. So you can just have it as V initial delta T plus half G delta T squared in that way. Okay, now the next one is that one. V final squared equals V initial squared plus 2A delta X. Again there, that should have been delta X. Now, how is it going to change? I think you know from now. For delta X, we should be seeing delta Y. Okay, so here it will be 2G delta Y in that way. Okay, and like I said, you don't have to show all those things. I know people do get confused when they see a lot of writings and marks on things. So you can remove that and just say V final squared equals V initial squared plus 2G delta Y. That is good enough. So those are the equations as you should know them and you should understand them. Now, finally, how do we use these equations? Okay, how do we use these equations? Look, if you are asked to look for time, for example, you are to solve for time, how long, and you are given final velocity and initial velocity of that projectile, definitely you can use this one. But you can't use this one. Why? In that situation, because you are not given the height, how far the object moved, delta y in this case. So it will be delta y, you're not given that. But if you're given the height and you are given the time, you are asked to find the initial velocity, you can use equation 2, this one. Or you can come down here and be able to use equation 3. If you do have final velocity, you do have the height reached, or the delta y in that case, and you're looking for initial velocity, can do that. What I'm trying to say here is that list your values of what is given and begin to say, what is it that I'm looking for? And choose your equations appropriately according to the information that is given to you. And that's how you can use these equations to solve the problems related to projectile motion. See you in the next section of the lesson.